Okay, YouTube, in this video, we're just going to look at a modeling situation in which we have a composition of a couple of functions here, and it involves a square root model. So let's go ahead and take a look at what we have. It says the function e of d equals 1/4 the square root of d. This approximates the number of seconds that it takes a dropped object to fall d feet on Earth. And so this is our Earth model here. You notice this Earth model is a function of distance, I'm guessing here. And so we say the function S of d equals 4.4 times the model that we have for Earth. So we say that approximates the number of seconds it takes a dropped object to fall d feet on Saturn. So you can see that Saturn's model basically, we say, is basically 4.4 times as big as Earth's model, but that rule really works. So what we're going to do in this video is write a rule for S and basically determine how long it takes a dropped object to fall 15 feet, I guess. So let's start with this. Write a rule for S. And so we know S of d. I'm just going to rewrite this here. S of d is just 4.4 times the size of Earth's model, E of d. And so because we know E of d is this 1/4 the square root of d here. I'm going to change my color here. I don't like either of these. 1/4 the square root of d. We're going to plug that in for E of d here. Let's go with, why not? So we're going to plug this in for E of d, and we get really Saturn's model here is 4.4 times 1/4, 0.25, the square root of d. And so here's really our model. And you know what, I'm going to grab a calculator here. I've got this one out here. We say 4.4 times 1/4. I think that's got to be 1.1. So we say 1.1 times the square root of d. And we're going to write what this is. This is Saturn's model. And so with respect to Saturn here, we said how long does it take a dropped object to fall 15 feet on Saturn? Well, you know, in terms of its model here, we have 15 feet is the distance that we're plugging into it. So we'd have really feet, or don't let me write feet here. Let me write distance. So we say distance, and then I can tell you the time that it takes to fall that distance here. And so what we're saying in this particular instance is if we plug in a distance of 15, like, you know, how long, let me write Saturn's here, how long is it going to take it to fall that distance on Saturn? So really what we're going to do is we're going to go find S of 15 here. We've got a time value, or a distance value. Let's go plug it in and find out what this equals. We get 1.1 times the square root of 15. And certainly I just would use a calculator here. 1.1 times the square root of, and we'll type in 15 in parentheses. And it would take about 4.26, and I'm going to say, you know, approximately 4.26. I don't have to write the approximately sign. We'll just say up to 2 decimal places, about that. And this is in seconds, so seconds. And just to make sure I read the directions here, it says how long does it take this? It didn't ask me to round, so we'll say this is approximately okay right here. Yeah, cheers.